Yes, ma'am. We can start.
Okay. Good evening, everybody. Every teacher needs to improve, not because they are not good enough, but because they can even better. With this quote, I welcome all of you for this fourth day of faculty development program on mathematical tools. Today, I am very privileged to welcome our resource person, C. Selvakumar, PUMS, Srinivasapuram School, Krishnagiri. He is going to give the topic on the topic Desmos. Welcome you, sir.
Welcome, ma'am. Thank you.
I am elated to welcome our Chief Executive Officer, Dr. K. Karnagaran. Welcome, sir. Deans of the institutions, and I extend my warm welcome to all the active participants. Before handing over the session to Kartika, my special thanks to both student coordinator Srira and also the faculty coordinator Kartika. Welcome you all. Once again, I hand over the session now to Kartika. Kartika.
Okay, ma'am. Never stop learning because life never stops teaching. With this quote, very good evening to all. On behalf of Hindustan College of Engineering and Technology, Department of Science and Humanities, it's my great pleasure to welcome you all for this session. Today being the fourth day, I feel honored to welcome our resource person, Mr. G. Selvakumar, BT Assistants in Mathematics, PUMS Srinivasapuram School, Krishnagiri. He is going to give a talk about Desmos. He is very much interested in developing creative ideas for school children. He got a July Award from Universal Teachers Academy for creative videos. He is also interested in yoga and marathon, and he won third prize in district level marathon and yoga. Without taking much time, I hand over to our speaker. Welcome you, sir.
Welcome, ma'am. Thank you. Greetings to one and all. Am I audible, ma'am? Is it okay?
Yes, sir. You are
Yes, sir.
audible.
Yes, sir.
Okay. Thank you. Thank you. Greetings to one and all. Before start the session, I would like to thank my master, Mr. Ganesh Andu, and thank you for this wonderful opportunity for the Hindustan Engineering College. It gives me a warm welcome and pleasure to be grace of all your presence in the entire committee. I hope that I will do some best in this session. Um, Now I'm going to share my screen. Is the screen is visible?
Yes,
Yeah.
sir.
Okay. This is the topic we are going to discuss about the Desmos. Okay. What is Desmos? So this is the topic we are going to discuss. Desmos, graphing calculator. The technology can't replace teachers, but without technology, learning is not fruitful. Is it? Okay. So what is the Desmos means? It's an advanced graphing calculator implemented as a web application and mobile application in written by JavaScript. It was founded by Eli Lubrov, Max and physics double major from Yale University, launched on 2011. It is not an offline mode, so it works in online. So it is a free and open source online software and teaching learning process. It helps the student to learn math and love learning math. Focus, not math, not a tool. It also helps the students to puzzle and unpuzzle themselves. Desmos helps students and teachers to learn very easily, which means user friendly. And it can understand the concept is easier and it can create some arts in Desmos. So what are the constructions means? The construction of quadratic graph, finding solutions, quadratic equations, and the nature of curve through graphs. Desmos used it to teach 3D shapes, analytical geometry, and calculus, etc. It is mainly for the higher classes. You can see the calculus subject too. There are 3 screen types. So, okay, now I'm going to Google, type Desmos. Most of them familiar with this topic, but good things must be repeated. I'm going once again, the Desmos. Before that, you have to sign up. Okay, for a sign up, there are two options. One is the external account and another one is the email address. I created already an email account in Desmos. So the past nickname, something like you have to keep. So So before that, you have to sign in. Yeah, I have signed it. And what are the tools means? You can see the mathematics tools, graphing calculator, scientific calculator, four function calculator, matrix calculator, test practice, and geometry tool. So these are the tools we are going to discuss here. And the classroom here for teachers, for students, Desmos curriculum. Here you can see the Learn Desmos. All those features will be in the Desmos. So I'm going to start a graphing calculator now. So you can see the coordinate plane, is it? You can drag wherever here. Here is the graphing settings. First of all, you can hide this expression, and in the graph settings, you can see the, if you press this capital A, the line will be thicker. If you use the reverse contrast, it will be in a black color, and this Braille mode for visually impaired children. And if you want grid, you can keep grid, or you don't want, you take. If you want arrows, these are the features in the Desmos. So if you add a label, you can add a label on it. In y-axis, that depends on you. Okay, now okay. So let us plot some points. This is the input section here. Here you can see the input section. What are the input section here is f of x expression, the functions, notations, and note, table, folder, and image. So let us plot some points in the graph. Some 3, 6. It won't appears on the graph. You can see, you can drag it wherever you can keep the coordinate plane, wherever as you wish. So this is not appears. Why? Because it should be come with a bracket. So 0.3, 6. Okay. So the point appears. You can see here. Is it? There are 6 colors. 1, 2, 3, 4, 5, 6 colors. You can choose what color you want. You can choose it, and you can what are the lines, which points you like, that we may take it on. Okay, this is the plotting of the graph. So plotting of the points. Sorry. Next, we also do some animation in the Desmos. Okay, if you want to keep, if you can keep like this. So let us add a folder. I'm going to give some demo animation. So I'm adding demo animation. Before that, I'm introduced to this is the table function. This is the key functions. Whatever you want to write, you can write this. There are many options. Yeah, the functions, sign, trig, stats, miss. So these are the functions here. So let us use this. So we know the equation for sin x, is it? F of x equal to, sorry, sin x, the wavelength of sin x, is it? So let us keep this point as 0.5. Okay, it's fine. Now you can drag like this, and what you have to do is, and insert an image. You can insert an image here. I taken the cycle, bicycle. Okay. Let us resize this image. Let us resize this image. this cycle has to move along the x-axis parallel to the slope. So what we have to do is f of x equal to sine x is the wavelength. Next, let us write the function for the slope. So g of x is equal to d by dx. You can use the functions here also and as well as in the keyboard. Now function f of x. Okay, you can hide this one. If you keep, you can hide this. Okay, then we have to move this along the slope of x-axis, is it? So what we have to do is, let us centerize this a. So add a slider a comma f of a. Add a slider, but it won't move if you add the slider. Okay, it is not perfect, it is not up to the mark. So go to the angle. So let us change the angle. So g of a, set of a. Now it is okay, not up to the mark. You can hide this. Okay, so but not it is up to the mark. Let us add some points here. Plus 2. Okay, it is perfect. That's it. So these images I got from Pixabay. Okay, let us see that. Let us move slow. Yeah. I think we have to reduce some more points here. If you want this, if you 2 or 4, it go high. If you want 5, it goes higher. Then 1.9. Okay. Now you can see it. Okay, let us move to the next part. Suppose you are going to give some sums for the children. It may be a linear equation or anything like that. Suppose I'm going to try it as solve a linear equation. So something 5x plus 3x equal to 72. So 5x plus 3x will be 8x. So the value of x is 9. So how to plot this point on the, how to solve in linear equation in the Desmos graphing calculator. So 5x plus, as soon as you write on some letters or words, it appears instantly on the graph. 5x plus 3x equal to 72. You can see the points here. So the value of x is 9 and value of y is 0. So this is the linear equation. So you can give simultaneous equation also. So let us try one more. 7x, sorry, 7x so it is not clear. Okay, 7x minus 3y is equal to 13 and 5x plus 4y is equal to 40. So solve the simultaneous equation. How to solve this? Let us use the graphing calculator. I'm going to take this one. So 7x minus 3y is equal to 13, and then 5x plus 4y is equal to. So you can drag the points. You can drag the coordinate plane where you have to see here the points here. So the value of x is 4 and the value of y is 0. Okay. Are you able to see this one? Yes. So the value of x is 4 and the value of y is 5. And then we go to another one. So let us do some art in the Desmos. So graphing calculator. So we know the equation of circle, is it? So we know the equation of circle, x square plus y square. Let us claim as 25. Okay, the circle appears. Okay, if you want reduce this, you can reduce the shape as you like. If you want to change the color, you can change the color as you wish. Then we write the general equation of the circle, x minus a square plus y minus b whole square less than or equal to. So we want some I for that. So I'm going to take 0.5. So add all those things. So it's coming as disappears. So it is bigger. So let us select some other. Let us select x value as x plus 2 point. Somewhere it is in the x-axis. Is it 2.3 whole square plus y minus 2.1 whole square less than or equal to 0.5. Yeah, it appears. It is in the second quadrant. Okay. So let us take another one. Let us copy this one also. Minus 3 less than or equal to y less than or equal to minus 1. So bracket minus 2.5 less than x less than 2.5. So we have drawn a. So we have another. Let us copy this one. Control C and Control V. So here x plus, let us give minus 2.3 and y plus. So it appears. Okay. .5 or 3.5. So some creation of we can do in this Desmos art graph. You can see some saved graph here. So this is the Desmos art graph. You can see here, which I have already done this. X square plus y square less than. So this is the points you have to add it on. So like this you can try. So what is the use of art means? It encourages the students to explore their functions, and also it includes the straight lines and the curves. You can see here very clear. So if you manage this one 0.4, it is differ here. So the lines that depends on where you have to create it. It is. So what is the use means? It encourages the students to explore the graph. Then Desmos are conducting the art contest. So you can see the arts. So here you can see here the age of 13 to 14, age to 15 to 16, age 17 to 18. So these are the graphs they have done in the Desmos. So they can develop the habit of creativity. It's coming. Yeah, you can see here. So these are the artwork in the Desmos. So it can able to do this the first place and second place and third place. Now let us move to the another topic. So the topic is, you can see the stage of apples. The stage 1 5 apples, stage 2 8 apples, stage 3 11 apples, and stage 4 14 apples, and stage 10. So let us do what is the stage in the 10th apple. So graphing calculator. So I'm going to insert a table here. So the stage 1 has 5 apple, is it? And the stage 2 as it instantly appears here, you can see here. Okay, and the stage 2 has 8 apples, and the stage 3 has 11 apples, and stage 4 has 14 apples. And what will be the stage of 10? That is the question mark. So you have to add one more thing. You can see the points instantly appears here. So you can add almost one more thing as y2. So this 5 can be written as 3 plus 2, and this 8 can be written as 6 plus 2, right? Yes. And the 11 can be written as 9 plus 2, and 14 can be written as 12 plus 2. So what is the stage of 10? So that's why I have to find out. Let us put another y3. So these are the pattern of coming like a third table. So let us use the function key here. So 3 into 1 plus 2, it will be 5, is it? So 3 into 2, 3 into 2 plus 2. 3 2s are 6, 6 2 plus 2 is 8, and 3 into 3 plus 2 is 11, and 3 into 4 plus 2, it's 14. And what will be the 10th stage means? It's 3 into 10 plus 2. So the third stage, the 10th stage is 32, is it? 30 plus 2. So the 10th stage will be 32. This is the answer. You can see the points here. So what is the use of this means? Children can easily understand the table and the pattern of learning this. You can use this for pattern work also. Then we will go to the next session, next one. Let us understand the equation of line and parabola. I'm going to select this new again. Let us select new graph. So every time you can save the graph, new blank graph, you can save the graph here. Now I'm going to introduce the line, understanding the equation of line and parabola. How to understand the line equation? We know the equation of line is y is equal to mx plus c. Is it y equal to mx plus c? If you add the slider, it comes into the pointer. So this is the point. It's called y-intercept, and that is the gradient of 1. Is it? You can drag the points here. You can drag the points and coordinates here. You can see when the parameter changes, the gradient is also changing. You can see clearly when the parameter changes, the gradient is also changing, and the graph is tilting sweeper. Is it? Now you can change the C. It is in the y-intercept. Is it? You can see very clear. Yeah. Okay. So the points are tilting in the same. When the parameter decreases, it will decreases. Is it? The y-intercept is moving with the same gradient. So that's why the line of equation is y is equal to mx plus c. Let us do another one. Understanding the understanding the parabola. So the equation of parabola, we know that y is equal to suppose a into x minus b whole square plus c. A is equal to, so if you add all those things, so the parabola comes. Okay, a affects the change of the graph. You can see a affects the change of the graph. Now I'm going to drag this one here. A affects the change of the graph. You can see, and b goes left and right. B goes left and right. Is it? And C is tilting downwards and inwards. Okay. Now what we have to do is, suppose we are putting A is 1 and the value of B is 0 and the value of C is equal to 0. What will happen? We will get the parabola. Is it? Here is the y-intercept, and if you add the table also, if you add the table for x-intercept, it is y, and what is the y-intercept? It will be 1. If you add 2, and it will be 4. Okay, you can see here. So this is the point. So this is the equation of parabola. Now let us do some animation in parabola. Let us new blank graph and insert an image. First of all, I am going to insert an image here. Yeah, it's a parabola. Okay, I inserted an image here. This is the parabola equation. We know the equation of parabola. Y is equal to ax square plus bx plus c. Okay, so I already told that a affects the change of the graph. Is it? And b is moving right to left, and c, it moves inwards and upwards. Let us keep what is the point of A and what is the value of B and what is the value of C. So let us move here. It is going down. Okay, let us try this one. Yeah, it's coming. Okay, You can do this. Yeah, it's okay. It's fine. So the value of A is minus 0.6, something we have to try. If you keep on trying, it will comes. If A is equal to 0 minus 0.6 and B is 0.1, C is 2.4. You can share this graph. You can also share this graph. Okay. Then we will move to the Desmos. Okay. So what are the tools we are going to learn? Let us go to the geometrical tool. So here this geometry tool. Yeah, this is the geometry tool. There are two types, the construct and the transform. So let us take the segment line. I'm going to draw one segment with this point. With this point, we can every time you have to use the select because the command will be active. So I take in a segment. With one segment, with this one point, I can rotate many times so that I can get a clear image. So let us go to transform and define transformation as define transformation, select rotation here. This is the point. Choose the point as you like, and suppose I'm going to give as 30-degree. Okay, and select. You can apply it. Okay, let us do one more thing. So I'm going to one more time. It's a segment here, and you transform it and define transformation. I'm going to rotation it and choose a point. I choose this point as the rotation. Now you can apply this angle 30, and if you select this image and you can apply it. Is it's working now? Yes. Now you can add a segment to this. Okay, now this is the point we have selected. This is with the center of point we have selected. Go to select, and you can move this whatever as you wish. So this makes something interest to the children. And what is the angle for this one? And what is the name of this? Name is dodecagon. Dodecagon. And if you create an angle for this one, and what is the angle for this one? For an angle, we have to select 3 points. Is it 1, 2, and 3? So the angle is 30-degree. Okay. So if you want this all angles on all the sides, just select this one and go to transform and select. You can see all those points. Once again, apply. Okay, you can see this one. You can move whatever as you wish. This is something So one object, that is one point. With the one point, you can create all those angles and with this, suppose I can change the angle as 90 degree. So you can see the square. That's it. So many more things like this. Many more things like this. So this is very interesting in the geometrical tool. And one more thing is, we will see with the same object as a, so construct a polygon. I'm going to take a new graph. So construct a polygon. Let us take this polygon. So sorry. So polygon here. So if you, every time you have to go for a select, because the command will be active. So if you select this as a polygon, so what you have to do is, we have to transform with a 1 point. Is it? So we are going to take this as a dilation. So we got for a choose a point. This is the point I'm going to center it. So I'm going to take it as a scale factor as 1. Then transform it into, you can apply it. So it is very good. So you can change the color also. If you don't want the color, you can change the color also. The color is here. Yeah. If you want orange, you can choose orange. First select and then you can give that. Yeah. Okay. Somewhat the error is okay. Now I'm going to transform this object. So transform rotation. So where the point you want to choose, you can choose wherever this point. I'm going to choose this here, and then I'm going to apply it. You can see? Yes. With this point, you can see this. So this is the one of you can do in Desmos. So another one, we are going to take a circle here. So every time you have to go for a select, otherwise the command will be active like this. If you keep on going like this, so every time you go for a select tool. So this is the circle here, and you can select it and you can keep the points here. Let us select one more point. I have already told this. You can press this. Okay. You can change the color also, but unfortunately it is, yeah, it's okay. You can change the color as you wish. It's a color here. Then you can label it. For example, I'm going to label it as O. And for this one, label it as C. So let us take some more points here. So I'm going to draw a segment here. We can demonstrate the circle theorem. We are going to demonstrate the circle theorem here. Now with this, and again, yeah. So what we have to do is with this angle tool, we can able to demonstrate the angle of the center is the half of the angle at the circumference. Is it? To create an angle, you have to select the 3 points, 1, 2, and 3. This is the angle here. And for angle, this one, is it? Yeah, you can move it. Select tool. You can move it as you wish. With this, we can able to tell the children for cyclic quadrilateral properties and tangent to the circle, and actually the angle is off to the angle of the center. So with this we can do this. So suppose we have to draw a tangent to a circle. Let us take the segment line here. Okay, let us take the segment line, and there is a more tools. Every time I've told you to select here and more tools here. It's a perpendicular line, is it? So I'm going to select this one. So this is the angle is 90 degree. So what you have to do is, so the angle is 90 degree. So that wherever it goes, its tangent is 90 degree. You can move this. You can see this. So wherever it goes, the tangent is 90 degree. Okay. Finally, we will do some other in the circle. Let us do some reflection here. So let us do the reflection. For this, we are going to select a circle. Okay, we've selected a circle. So, and then transform it to a rotation. Choose a point where you have to choose it. You can choose this point and you can apply it. So wherever the point, you can choose it and apply it. So let us do some reflection here. For this, I have to draw a line segment, and then I'm going to take this polygon. Okay. So let us reflect this one. So go to transform, and there is a reflection, the first one, is it? Choose this one. If you choose this, and if you choose this, and if you apply it, it gets reflected. So same as it the concept we can use for the circle also. So circle, actually dilution, choose a point of center, and scale factor you will give 1, then you apply it. So it gets, so line segment, so transform in that reflection, is it? We have to get reflected. Select this one and you select the object, it will get reflected. So with this, so this is the line mirror, you know that. So with this we will go to the, what are the tools, what are the other tools, we will see that. So you can test practice, you can use these tools for test practice too. So graphing calculator, so start practice with this. For example, f of x equal to 2x plus 5x. So what is the value? 2x plus, so you get the answer. Okay, with this table we can do this. And the next one is matrix calculator. So these are the tools here. You can add a new matrix. So 3 cross 3 and 3 cross rows. Suppose I'm going to give some numbers here. 5, 6, 5, 6, 8, 9, 3. So this is the matrix here. Now what you have to do is you can enter this one, and you can see this a square. If you get a square, you can't put like this. Select a and square, you get this one. Okay, and the transpose matrix, next enter one, and you get a inverse. Okay, a so a inverse, the value of a inverse, and enter, and you select the transpose matrix a power t. Is it a t, the transpose matrix? So those things can be done in the matrix calculator. Okay, so there are some other features also. You can square root it, and then whatever this want, we have to square root, and the addition matrix and subtraction matrix, those things are there. You can try this. Okay, and let us see the 4-function calculator. So the 4-function calculator is nothing but arithmetic, total, addition, subtraction. So this is something easy. You can easily understand this one. Square root of, you can give sums for this children. Square root of, for example, 2 to 5. Square root is 15, and enter, and square something. Square root of 369. So this is something you have to do, practice this one. Okay, and the next one is and the next tool is scientific calculator. Let us do some scientific. So here, the for higher classes, sine 30 degree. Okay, sine 30 plus cos 90. You can give like this sums. For here, the functions are, you can see the functions here: degree, sine theta, cos theta, sine, cos, tan, and a power p. Suppose we can choose this. Suppose I'm going to take a power p. Suppose I am going to do for a small sum 2 power 10. What is the value 2 power 10? Is 1024. Suppose I'm going to give this 6, so the value of is 64. So these are we can try this in the scientific calculator. There is more options are there. You can try all those things in the calculator. So this is the basic something. So finally, I'm going to take one more time. So what are the graphing calculator? So you can the angle measurement of the sum of the angles is 180 degree. You can do the like this also. You can see here. Okay, you can see. The sum of 3 angles is 180 degree. You can do this one also. So this is the equation. You have to type this one. Okay, for there will be a seminar in the Desmos. You can also join that one. So these are the graphs. You can do this. It's easy to understand this. So these are the graphs actually tried in the home. Okay. So these were the max tools we are going to I hope you have understood all those things. Let us give them polygon. You can do it whatever. You can measure an angle. So if you want this, you can select a color here also. So the angle, so the sum of three angles is 180 degree. You can and give the concept here, and so this is the properties, and we can give vectors and arc for this also. So with this, I'm conclude my session. Thank you for this wonderful session. Hello.
Yes, sir.
Any
Thank you, sir.
Thank you.
Participants, kindly post your queries in the chat box. Sriram, is there any queries?
No, ma'am.
Okay. Shall we conclude it, sir?
Yes, ma'am. Yes, ma'am. Thank you.
Okay. It's time to give vote of thanks. Good evening to one and all. Thank you, sir. It was such a wonderful session. I hope that it was very useful to all of us. Thank you, sir, for accepting our invitation. Next, I thank our HOD ma'am, Dr. KP Uma, our student coordinator, Mr. Sriram, and all the active participants who made this session a successful one. Thank you, one and all. Thank you, sir. Thanks a lot.
Thank you, ma'am. Thank you, ma'am.